what will be the diameter of those rods, and then determine the base plate thickness. These two things. Now from the geometry you have to find what is M. M is this distance, right? You can calculate this distance from the figure. So this is 22. 22 minus 16, and then divide by 2 will be your M. This is M. This is M. Right? So 22 minus 16 is this total, and half of that will be your value of M. So you get M. Similarly, X you can calculate by that formula which you have already seen. Okay. So based on that we find the value of X in the previous one. If you remember that figure.
Can we see the picture?
Huh?
How to get the X?
X again go back to that initial. See this X. This is your X, this distance from the figure on your slide number 12. So X is calculated based on this F minus D by 2 plus TF by 2. TF is thickness of the flange. Okay?
The distance between the center of
this is F. Yeah, from this center to the center of these bolts. Okay? From the center of your plate up to this center. That is F. So we have calculated this distance X, which is F minus D by 2 plus TF by 2. From here we just substitute. So X is now known to you get the value of X. D? Where? Yeah, D is this depth. D is this depth. This is D. This is D.
From the center or the end?
End to end.
Okay.
End of this flange to the end of this flange. That is D. And this distance is only 0.95. We see this line. Only 95% of D is considered. Okay. Yes. So now with all this geometry, we can calculate these values. So X, now you understand what is this X. We substitute those values. Okay. Then eccentricity. How much will be the eccentricity? E is equal to M upon P. Right?
Yes.
M how much? 120. This is M. And PU 130. So we write here 120 feet cube multiplied by 12 because now you are converting into inches. Divide by PU and you get 11.08 inch is the value of eccentricity. This case. So now you get the value of P. Then we find how much is N by 6. This is your N. So N by 6 will be 3.6. So this N by 6 is less than the eccentricity.
That's mean what?
That means case number D. Okay? So we get this because eccentricity is more than N by 6. If it is up to N by 6, it means it is case number C. If it is less than N by 6, it is case number B. If E is equal to 0, case number A. These are the 4 cases, and based on that, you will decide which formula you will use for thickness or the tension, all these things. Okay, so we decide first which case you have to use. So we go according to that and calculate those things. Now Q will be the pressure which you are calculating for that concrete. So we will get this formula 0.51, and this is your F prime C value, which comes from here. F prime C you have taken. This is for this grouting. Okay. This is that grouting. So we have taken this 6 KSI and then this value from that distance we get how much?
20 from what?
Huh? 20 inch. Yes. From where you will get this? 20 inch. Huh? How much? 0.51 into 6 KSI into 20 inch and then into square root A. Which value is 20 from this figure? See that?
Yes.
Okay. Yes. So just go back to that formula for Q which we used earlier. Initially the formula for Q you will see
Before.
before this, yes. Before this
Yes.
formula.
Okay.
Right? 0.51 F prime C B and then square root of A2 upon A1, right? So based on that, we find the value of Q, which is the pressure of concrete. So we get these values and then we find F plus N by 2 because we need this F plus N by 2 and F plus E to find the value of Y. Right? Just because we already have the solution for Y by solving those quadratic equations. Where is that? Value for phi, value for Y was calculated. Huh? Slide number 12. Slide number 12, maybe slide number 12, which we finished on Sunday.
Yes.
Yeah, Sunday, yes. After this, yes. See here, you need these things. N by 2, Y by 2 plus F, and you need E plus F to get this value. Everywhere you have F plus N by 2, you have F plus E. So when you substitute, you will get the value of Y. That's why we are calculating these numbers. F plus N by 2, F plus E. Right? Everywhere F plus N by 2 or F plus E. PU is already known, Q you have calculated. So when we substitute this value, you will get the value of Y. Okay. And known to you, F you have just now calculated. So when we substitute here, we will get the value of Y. Y is the bearing interface. How much of that concrete is being compressed? Okay. And that will give you the idea of the pressure on the plate. So we find this value F plus N by 2 and F plus E. E you have calculated here. This is the value of E, and F we have also calculated. Okay. So now we find this value of this Y. So we find the value of Y, which is 19 here, F plus N by 2 in that formula, plus minus the square root of this. So it is coming from that class on Sunday, right? The value of Y. So once we find this, Y is 2.27. Now look here. There are two possibilities for the value of Y.
Yes. Minus.
Another files.
Yes.
Two values for the value of Y. 19 plus minus. Plus minus square root of this number. So if I put here this value with plus, what will you get? 19 plus 16.73. How much? 35.73. And if I put this with minus sign, 19 minus 16 point something, that is 2.7. So which value you should take for Y?
Small.
Huh?
Small value.
Small or the big?
Small.
Huh?
Small.
Small? Sure.
Yes.
Not big.
Check the positive.
Huh?
19.
Check the positive?
19 positive there.
No.
Which is 35.
Look for the possibilities of this Y. Don't look for small or maximum. Okay. This Y is what? This Y is the interface of concrete and the plate. Look here. The maximum value of Y can be only this much.
The 35.
The plate, this is your plate. Plate has only the length of 22. So there is no question of concrete and steel having a coverage of 35. Maximum it can be 22. Right? Because concrete will be under the plate here. It can be less than this 22 or maximum 22. Okay? So we have the other option, and this is okay 2.27, and this happens in the case of the moment. Only some part of your concrete will be in compression. Right?
What if there are two values applicable?
Two values.
Yes. If the
Which
two-
value? Here,
Two values.
suppose here you get 5. Huh?
Yes, 5 and
So which one you should take?
5.
5. Okay? Because that will give you more
More.
pressure. Okay? So in that case, now we have the value of y, the bearing interface, so maximum. Now TU is equal to 61.2 kip per inch. This is there, and we find this number minus 130. Okay, we have this value. This load is in this direction, right? And you will get this 16.2 from here. This is your pressure, which is 61. That is pressure of concrete. That pressure of concrete is in this direction. This is your Q. And for how much length? The length which is under compression is only 2.27. Okay. So this is pressure of concrete. This much is the length, and we are calculating for only 1 inch per inch. So you can say okay for 1 inch. So this is area. Okay. Stress, which is kip, and then already we multiply by 1. So you get, and minus 130 is the load. So this whole thing is just in kilopound. So finally, the force on these rods will be 8.92 kilopound.
B is given,
Yeah?
Russia, 61.
61 we calculate from here.
Yes.
Yes. This 61 we calculate. This is the bearing pressure on concrete. So bearing pressure on concrete, and how much is the length? Which is,
You got it.
this is your length y. Y. The length of concrete which is compressed. Okay. So we get the tensile force, and that tensile force will be taken by not concrete, because concrete cannot take any tensile force. So that tensile force will go to the bolts on this side. These bolts will not take any because they will be in compression. Okay. Only these bolts, because your bending will take place like this. So this will be compression, and this side will be tension. Okay. So we have now the tensile force. Okay. Now your job is to start the design process. Total force of tension you have seen. Total force of tension is only 8.92 kilopounds. Now you decide how many bolts you will be providing, and for that you decide the capacity of one bolt, and then that will be deciding how many bolts will be required. If your force is 8.92 and you have a bolt of suppose 5 kilopound capacity, so 8.92 divided by 5 kilopound, which is capacity of one bolt, and that capacity comes from your knowledge of tension member, right? So you can calculate the strength of your tension member. So based on that you find the strength of one bolt, and this is the tensile force which we calculated just now. So this will give you the number of bolts in tension, which is 8.92 divided by 5. So you can say okay 2. It will not be 1 point something, 2 bolts, right? So that depends on the capacity of your bolt, and which is depending on the diameter. Okay. So diameter you have to decide. Here it says that the bolts, these bolts, anchor rods also are defined as A307. The bolts which you have to use are made of A307. So grade is also given. So based on this criteria, you will decide what will be the capacity of your board. So you know diameter is required because Fy value will be decided by this. If this is not given, it will be your choice. You will select. But now in the question, the Fy value for grades will be according to this criteria of anchor rods. So here we come to now we assume that we will be using 3 by 4 inch diameter rods. Now the diameter of rods you will be selecting. So we select the diameter of the rods or the anchor bolts as 3 by 4 inch. Somebody can say I will take this 5 by 8 inch or 1 inch. Okay. So that will be your selection. So now here in this one we have to select the diameter of the rod. And minimum how many should be there? Minimum 4 bolts should be there on the plate. At each corner, if this is your plate, at each corner there should be 1 bolt at each corner, minimum. So minimum 4 bolts are required for your plate. So if we say that okay 4 bolts are minimum requirement and I say that okay I am taking 3 by 4 inch. If this 3 by 4 inch is sufficient, I will continue with this. If it is failing, I will have to change the diameter. I say okay 1 inch. If 1 inch is also failing, I will take another diameter 1 1/4 inch like this. Okay, because design is trial and error. So BUB, which will be 30 divided by 4. So total force was how much? BU was given as 30, the shear force. BU was given 30, right? So for this 30, now I will check whether my bolts are safe in shear or not. Yes, Chandani? Okay. So shear force was how much? Shear force. How much was the shear force?
In the figure,
How much?
130,
Huh?
130, or 50, yes.
130?
Yes, yes, yes.
30. 30 is the shear force. So I have taken this. 30 is the shear force and then divide by, because I am using 4 bolts now. So how much will be the shear force on one? 7.5. So total shear force divided by number of bolts. So each bolt will have only 7.5. So now you can see here pi FVAB equal to 0.75. Now we use that same formula which we used earlier for those bolts. Here it is AB, area for the bolt, because bolt we are using 3 by 4 inch diameter. So AB is, how will you calculate the area of the bolt? Yes, area of the bolt. Which formula you will use for area of the bolt?
By
Dadi. Which formula you will use for area of the bolt?
The area.
Huh?
The area.
Which area? Which formula you will use for area of the bolt?
5 by 4.
5 by 4? What 5 by 4?
Area of the circle.
5 by 4?
Yes.
5 by 4 is the formula for area.
5 by 4 b square.
B square. Right? So in that case, this AB is equal to pi by 4 B square. In that case, you will get the area of the bolt which you substitute here, and this formula is coming from that condition here.
Should we deduct the value, the area of the throat? Should we deduct the value of the area of the throat? Yeah.
That depends on the situation, how this will be considered bolting. How much is the length of those threads? Okay, yes, in the shear plane or not. Okay, now I'll show you again that formula, FVB, all these things which you have seen here. Like this. Okay. So this, depending upon these bolts, you will decide what will be the value of FT or for this 307 or active board, and these are the values for your shear and tension. And similarly, the value of FV for 307 board will be taken as 24 psi.
Very long question.
Very long. It's just one page.
No, no.
One page only. This was figure. This was the question,
Yes.
and this is only your solution. This is one page.
Yes.
One page.
2 page, 3 page.
And everything is coming from the formula sheet. You get the value from the formula
It's
sheet.
long, doctor.
Huh?
It's long.
It's long.
But, if you can select the time, of course.
So how much time you will take for this calculation?
And will become, I know.
Huh?
And will become the final, right?
Why it will not come in the final?
Very.
Because you have only the base plate remaining. Otherwise, tension member, compression member, bolted connection, welded connection. I said only 4 parts.
Full
One question from this base plate,
5.
one question from welded, one question from beam, and one question from column.
You love like this
Huh?
question. You love like this question.
This is most important thing.
Yes.
Without the base plate, whatever you design, it will not be able to support the load. Okay. So in that case now, we find this, and this value comes out to be 7.96, which is how much? More than the force coming on the bolt. So it is safe. So we check that the bolt which we have designed is safe in shear. Then we come to tension. For tension, we calculate this value, which is 26.7 by using that formula for our bolt. So TUB is 8.92. That force which we calculated. Why we divide by 2? Why not 4? Why we divide by 2 here?
Because
Why we divide by 2? This was the total force.
Yes.
I told you that we are taking 4 boards.
Too long.
Only the outer boards will be taking the tensile force.
Yes, two for tension.
Tension only the outer 2, not all the force. Okay? Suppose it is 6, 3 here, then you will divide by 3. Okay? Yes. So only the outer boards will be taking the tensile force, not all. That's why we divide by 2. Total, we are taking 4 boards. So out of 4, half of that 2. Then we calculate here the tensile force Ft, how much? By using that same formula, we substitute here this value which we take from here, and then we confirm that this is 8.85, which is more than the capacity of this 4.46, and it is safe. So strength of your bolt, which is this is the strength, and the force coming to the bolt is only 4.46, so it is much stronger. Okay.
Number 5.
Yes. Then you can say, okay, select 4 bolts of 3 by 4 inch diameter anchor rod. One part complete. One part was this.
That's it.
Design the anchor rods. This part complete now. So you design the diameter and how many bolts, and you check. 4 bolts of diameter 3 by 4 inch, and now you check that everything is perfect. In the shearing and in tension also it is perfect. Now we go to the second part, determine the base plate thickness. Okay. Now we come to base plate thickness. The second part.
We just need to
And
design a bolt for compression side in the right.
no, bolt on compression side will be same. Bolt on compression side will be same, but tension will be only on one side, not on this side. These bolts will be in compression, because we are checking for tension and shearing. Shearing will be in all the bolts. Shearing will be in all the bolts, but tension will be only on one side. This side will be, if your moment is on this way, then this will be in compression and this will be in tension. Okay.
No.
Now we go to the second part, which is for base plate thickness. Thickness of the base plate. And in this case, we will follow those cases. Which case is applicable? This is case D, right? So in that case D, we look at this one. So base plate flexural yielding, Y value we have calculated in the previous one, which is less than 5.24. So M, N and N dash are not applicable. You will calculate by this formula.
5.24 from the data.
See that? Yes, from the data sheet. See this. This 5.24 you have calculated already. And Y value, see
It's condition.
here. Here is TP for case number D. When Y is greater than M, this formula. When Y is less than M, this formula. Now M values you have calculated already in your question.
Bigger than
M was how much? M was 5.24, right? And Y how much?
2.2.
Y is 2.27, right? So Y is
Greater.
less than M. So we have to select it. Okay. According to that, so we select this. And for that the formula is this one. In this formula we substitute all the values. Again you can see here
How we know the
Y less than M.
It's case D.
What is case D?
Moment.
When there is moment.
Yes.
So case D, moment. It is clear.
Case C also have moment.
In case C there is some limiting value. N by 6. Here it is more than that. You will decide by the eccentricity. So first you will check which case is this. And that we did earlier in the beginning. If you see here, we checked here. Depending on the value of E, we decided which case is this. Okay? That's why we first calculate the value of E and N by 6. That will decide whether it is case D. Now once you are finalized that this is case D, we come back and check, okay, the formula for case D will be used for plate like this. Y greater than M, this formula. Y less than M, this formula. So 2.11 PU, you know the value of PU, it is given.
Yes.
M minus Y by 2, also you know M, Y also. B into Fy. You have calculated the value of B already given, and Fy also for the plate. So you can calculate this value. Last or not?
And the thickness of plate.
So find this thickness of the plate, 2.11. In this case, 0.35, and here you get this value as 1.82 inch, and that value is there. Okay. Select the base plate 2 by 20. So 2 is what? 2 is the thickness, because the plate is 1.82 inch. You cannot take 1.82 inch. So you round it off to 2 inch. So take 2 inch thickness. Right? So your plate is 2 inch, and already these are the dimensions of your N and B, which are given to you in the question. So this is your plate, 2 inch thick, width B and N are like this. 1 foot 10 inch means this is 12 plus 10, 22. So N is given in the question as 22, right? Okay. Now the thickness is also finalized. Then we come to check bearing on concrete below grout level. It should not be more than the concrete capacity. Otherwise concrete will crack. Okay. The grout is 2 inch thick. Assume that the concrete extends at least 2 inch beyond grout in each direction. So we can calculate this value according to that formula. And we find that this value comes out to be 76.6, which is greater than the capacity, which is,
We calculated.
yes, here 61.2. Okay, only 61.2 is coming from concrete. So with that, now we check for bearing also, thickness of plate and the diameter of the board. So this completes your one question. 1 page,
Very
2 page, and 3 bay.
3 bay, no.
3 bay.
We will take it.
How much time?
6 bay.
Why 6 bay?
No, how many for now?
All the formula. This is not taking too much calculation. It's more just you will put the value and calculate. Here it is written in 2 or 3 steps.
The question will come like this.
Question will come like this.
Like
10 marks, is that?
You have
Not 10 marks.
same
Because you have how many?
4
4 questions.
Four.
And the exam will be 2 hours. So 30 minutes you will get for this. 30 minutes.
Yes.
Not 10 minutes.
30, yes.
Yeah, 30 is enough. For this question.
Same this time. Victor.
Same. Not describing like me. I'm explaining each and everything. Okay, how to do this? Chandali, you tell me. And you tell me, you tell me. That's why it takes time in the class. It will not take the same thing in your exam when you are writing. Okay? Don't think that, okay, because it is solved, more than 30 minutes, you will take too much time. Here, because I have to involve everybody, somebody is reading or writing something. Yes, Zadani. Yes, what are you doing?
Nothing.
See, now I am disturbed. Huh? And then I'm taking back. Okay, go to this page, this slide, that. Yes? Correct?
Inshallah, to be.
Correct.
So this is only one case.
Yeah, one case. So, depending upon the case, you will decide which case is this. Use the formula which is for that case. Okay. But the procedure will be same. And this is the case where you have moment also, you have shear force also, everything. In some cases, you may not get small, you will get small moment. Or maybe there is no moment. Case A. In case A, there is no moment. So easily, there will be no chance of any tension. Only compression will be there. So you will check only for shearing. No tension. The board. Okay. Now we come to another easy case where there is no moment. Right? I am giving you one example where
Same,
there is no moment.
same final exam.
Huh?
Same final exam. This.
Same final exam?
Yes.
Why?
Without moment, because the time, Victor.
Without moment.
Yes.
Huh?
Without both filter also.
We did.
Without board. Yeah, because base plate thickness will not take time. But for boards, it will take time. But for that, some of these items are required. Anyway.
Can you download this file?
Hmm?
Because I didn't see it.
Yes, Victor.
It's
The
not there?
file is not in the laptop.
Okay, today I will upload. So here we have this sort of example for the base plate thickness where there is no moment. Okay. Design a column base plate. This I developed for you. Okay, so that you will like for a small question. Very big question. But here in this question, the values of B and N you have to calculate. In the previous question, B and N values were given. Okay, here
Okay.
not given B and N. So there will be some small calculation required for B and N. How to find B and N for the plate. The question is design a column base plate, plant dimensions, that means width and depth, and the thickness for a W12 by 1996 column resting on 25 by 24 by 24 concrete pedestal. Take F prime C equal to 3 ksi and base plate yield stress Fy equal to 36. Assume A2 equal to A1. That already we discussed what is this A2 and A1. Okay. So first step is base plate area depending upon the load coming from the column, which is Pu upon 0.85 F prime C, because there will be concrete under the plate. Okay. So it will be decided by the strength of concrete. So A1 will be the area of concrete which will be compressed, and that we calculate based on this. So 700 is the load Pu, right? We substitute here F prime C is 3 ksi. In some questions it can be 4 ksi. So we substitute that value here. So this value of 5 will be taken as 0.65 here as per ACI. So 422 square inch comes out to be the A1 required. Now optimize the base plate dimensions N and D. This is something which is different from the previous. You have to find this number delta. How? Just based on this 0.95D minus 0.8 BF upon 2. Here, how you are getting this? I will take you back to that figure. That figure here,
Same figure.
first figure, first here. See this 0.95D here, okay, and 0.8 BF. So this will be your area from here. This is that area, okay. So from that you are just optimizing. So we find something which is delta, which is 0.95D minus 0.8 BF divided by 2, which is equal to 1.15. So n, how will we decide n? N will be depending on the value of this delta, which we have calculated. So n will be approximately equal to square root of A1, which we calculate from here, plus the value of delta, and delta we have calculated just now. So which is equal to 422 A1 plus 1.15, so it comes out to be 21.7. So we will not take 21.7, we round up to the next number, so it is 22. Okay. Now calculate A2, which is geometrically similar to A1. Here in this question it says, okay, A1 and A2 are equal. In some cases it may not be equal. If they say, okay, take A2 equal to 2A1 or something like this, you can take according to that. So we can say B will be how much? Because this area will be N into B, and you have decided 22, and area is 422. So 422 divided by N is giving you 19.2. Therefore 19.2 can be rounded off to 20. Okay. So you get the value for B and N. Now A1 is 22 by 20, and that is 440, which is greater than 420. Okay. So now we check PU, which is 5 into PP, and PP is coming from here. It is coming from here. 0.85 F prime C A1 into square root of A2 upon A1, because A2 and A1 are same in our case. So it will be just equal to 1. Then we substitute the value of A1 here, which is 440 here. So 0.65 is the value of 5. 0.85 in this formula, F prime C already given in the question. 440 just now we got this value, and this PU is coming out to be 729 kilopounds, which is greater than 700. Okay. Okay. So that load was 700 kilopounds on this, and the strength of concrete is 729, so it will be safe. Okay. Then we come to calculate the values of M. After this, it will be same procedure, right? To find the thickness, you will calculate M, because now you know the value of N and you know the value of B. So based on those values of M and N, you will be calculating this factors. you don't have y in this case equal to, because this y is equal and there is no moment. So here you will find this factor x, which is 4 dBf upon b plus bf. 4 dBf upon b plus bf whole square, and this is q upon 5p. All these values we have just now calculated. So this x is a number which will be helpful in finalizing your value for n dash. Now here, what is this d? D is coming from your column section, bf also from column, so this bf also from the data sheet. So when you substitute these values, you find x equal to 0.96. Then you can calculate lambda. This will be also in the formula sheet. So 2 into square root of x, x you have calculated here by this formula, and divide by 1 plus square root of 1 minus lambda, and this value should not be more than 1, maximum 1. If this value is coming out to be 1.23, 1.4, you will just keep it as 1 maximum. If it is less than 1, okay, keep that value. Suppose you are getting 0.6, you will keep this value 0.6. If by calculation lambda is coming out to be 1.1, you will keep it as 1 maximum. So maximum value of lambda is 1. So after that calculation, then you will find lambda n dash. So this lambda n dash you will calculate by this rule. So lambda we have taken as 1 because it was coming out to be 1.63. So the maximum value of lambda will be only 1. So lambda n dash now you put here, and n dash will be 4 dBf by 4, and in this case this is taken as this value dBf. So n dash you have seen earlier also. So d and bf from your data sheet, okay, for this column. So finally you get this lambda n dash equal to 3.11. Now find the number which is either C or L. You remember that in that question, in the slide it was C. So maximum of M, N or N dash was written as C. Either you take it C or L, the length, and then based on that you can calculate maximum value of M, N and N dash. Out of these three, whichever is maximum. So 4.97 was M, and N was 5.12, and N dash 3.11. So maximum is 5.12. So we take this value, maximum 5.12, and then T minimum required, which is T required, L into square root of 2 pu upon phi FYBN. All these values are available. You substitute and you can get this value as 1.6. You will not take 1.6 in, but you will take the value according to the thickness which is available in the market. Right? Every 1 by 8 inch. So according to that, you decide what should be the 1 and 3 by 4. 1, 3 by 4. That means 1.75 inch. Okay. This will be the value, and 5e for bending case will be taken as 0.9. And initially that value 0.65 was taken for compression case, where in the case of concrete, this 5e is for your plate, steel plate. That's why we are using here Fy. And when we are talking about concrete, we take F prime C, which was here, this one. So this phi was 0.65. Okay. This is the difference between this phi, which is for concrete, you can say phi C. If you want to differentiate, make it phi C for concrete case. And the next one is, this is phi B for concrete or for bending, which is 0.9. Okay. Next slide. Finish. Now, project work. Okay. Project, you have how many groups?
Four maybe.
No, total groups in your case. How many?
Three.
3 groups. Okay. Now show me your work. How much you have done in your project in the group. Sit in the group. Okay. Sit in the group.